Statistics for people who think they hate statistics. Neil Salkind and Bruce Frey. Here we are, beginning chapter 2. Means to an end, computing and understanding averages. This chapter introduces you to the following descriptive statistics known as measures of central tendency: the mean, the median, and the mode. The authors describe each average and discuss when each may be appropriate. The chapter concludes with practice items for you to extend your learning while applying these new concepts to real-world situations. So in this chapter, you'll learn measures of central tendencies, computing the mean for a set of scores, computing the median for a set of scores, computing the mode for a set of scores, understanding and applying scales or levels of measurement, and selecting a measure of central tendency. So measures of central tendency. The average is one value that best represents a set of scores. Another name for averages is measures of central tendency. Examples of this would be the mean, the median, and the mode. Now, when we're computing the mean, we use X bar as the mean value of the group of scores. The mean is the most common type of average. It's the sum of all values in a group divided by the number of values in the group. So again, X bar is what's used to indicate the mean. The symbol sigma is the summation sign, which tells you to add together whatever follows it. The X is individual score in the group of scores. A lowercase n is used to indicate the size of the sample from which you are computing the mean. So to compute the mean, you'll list the entire set of values in one or more columns. These are all the X's. You compute the sum or total of all the values. Then you divide the total or sum by the number of values. Things to remember. The mean is sometimes represented by the letter capital M. N equals sample size when it's lowercase. Capital N is population size. The sample mean is the measure of central tendency that best represents the population mean. It's also called the arithmetic mean. Mean is very sensitive to extreme scores that can skew or distort findings. That would be things like outliers. The weighted mean is a list of all values for the mean is being calculated. List them only once. You list the frequency with which each value occurs. You multiply the value by the frequency as shown in the third column. Sum all of the values in the value frequency column and divide by the total frequency. Now, the median is defined as the midpoint in a set of scores. It's the point at which 1/2 or 50% of the scores fall above and 1/2 or 50% fall below. Steps to finding the median. You list the values in order either from highest to lowest or lowest to highest. You find the middlemost score, and that's the median. But what if there's two middle scores? Then you'll take the mean of the two scores. If the two middle scores are the same, then it will be the same number as the two middlemost scores. Because the median is computed based on the relative position of the individual scores, not the value of the scores, extreme scores, known as outliers, are not able to adversely impact the median as they do the mean. Percentile points are used to define the percentage of cases equal to and below the certain point in a distribution or set of scores. So a percentile point and percentile ranks are two different things. The percentile point is the score, whereas the percentile rank is how that percentile point compares to the other scores. For example, the 75th percentile. So let's think for a second. Why is the median always at the 50th percentile rank? Okay, why would you use the median instead of the mean? Well, we would use the median instead of the mean if we had outliers. The median would be an easier measure. Things to remember. The mean is the middle point in a set of values, whereas the median is the middle point in a set of cases. Because the median cares about the number of cases, extreme scores, such as outliers, do not impact it. The mode. The mode is simply the value that occurs most frequently in the data set. The mode is the least precise measure of central tendency. Sometimes you will find that a data set has more than one mode. If two modes exist, the set is bimodal. If three modes exist, it is trimodal. To compute the mode, follow these steps. List all values in the distribution, but list each value only once. Tally the number of times each value occurs. The value occurring the most is the mode. Here's an example of finding the mode. Here's some examples of different types of multimodal distribution. Now, this is a very important lesson of central tendency. The three different measures of central tendency are not the same. Mode is best for categorical data like hair color or favorite type of music. Median is best when you have extreme scores or outliers in your data set. Mean is best when you have scores that are numeric, not categorical, and are not extreme. Scales of measurement. Levels of measurement dictates what specific measure of central tendency you will use. Measurement is the assignment of values to outcomes following a set of rules. Each of the four levels has a particular set of characteristics. So here are our four flavors of measurement. First, we have our nominal level of measurement. Nominal level of measurement is defined by the characteristics of an outcome that fit into one and only one class or category. These are mutually exclusive. Examples include gender and political affiliation. Ordinal level of measurement. The characteristic of things being measured here is that they are ordered. An example would be ranking candidates for a job. Interval level of measurement is based on some underlying continuum such that we can talk about how much more a higher performance is than a lesser one. The intervals, spaces, or points along the scale are equal to one another. An assessment tool at the ratio level of measurement is characterized by the presence of an absolute zero on the scale. Examples: 0 molecular movement and 0 light. When to use what? You use mode when the data are qualitative, categorical, or nominal, and values can only fit into one category. Keyword here being mutually exclusive. You use median when you have extreme scores, and you use mean when the data do not include extreme scores such as outliers and are not qualitative, categorical, or nominal. If you have qualitative data, you will use mode. If you have quantitative data, most likely you will use the mean or the median. Using the computer for descriptive statistics. The textbook reviews how to use SPSS to compute descriptive statistics. It gives us real-world stats. It provides a real-world example of where researchers examined internet use patterns using descriptive statistics. So here we can see frequencies and the dialog box from SPSS. Here we see an SPS output using descriptive statistics. So in summary, you will always start by simply describing what's there, hence the importance of understanding the simple notion of central tendency. Next, variability, or how different scores are from one another.